before, I'm really fond of this picture, which is a good description of how a modern enterprise is being run and the complexity involved in it. So the enterprise consists of, your own operation, of course, but then you also have a slew of different business partners, providers of technology and providers of capacity, of manufacturing capacity, reach to customers, et cetera, and then you have a number of end users or consumers of your services. Underneath the surface, you also have your business service operation, which is everything you do to provide your business services, IT business services. Some of that could be in your own data center on-prem. Some of it could be outsourced. Some of it could be running in the cloud as either an infrastructure as a service, but can also be software as a service. So many different ways to provide those services to a large group of different type of users and consumers. So in order to get this, to optimize this and to guarantee the quality of your services, you have to do a number of different things. So from a bottoms up perspective, from a IT performance and capacity perspective, you need to provide or gather performance metrics about how your infrastructure is being used, compute, storage, network, etc., throughput and latency of your systems, seasonality patterns, how different workloads are performing that may be sharing the same infrastructure, etc., etc. So a number of different quite technical performance monitoring metrics that you need. You also need to have business service metrics. So you need to contrast your technical performance metrics with something that gives you an indicator of business activities, so business transaction volumes, end user experience. So what is the response time of our applications and services we provide? What is the quality? What is the perceived quality? Is there any delays in our processing? So do we finish the work that we have for a lot of time, or is there a backlog that we need to work off hours, etc., etc. Once you have those two, you can start to do predictions. So you can start to try and understand the impact of new initiatives or changing priorities in the business, or new demands that are being presented to you, etc., etc., and try to forecast those, try to be proactive and build capacity or provision capacity to meet those demands in a timely fashion. And then over time, when you do this, you need to review in order to optimize your processes. So you need to understand how well did we do these forecasts? Were they, technically valid, but also from a organizational perspective? So are we constantly overestimating the impact of different marketing campaigns, for example, or is there a bias towards, a certain behavior, et cetera, et cetera? So trying to improve your processes and this continuous improvement of the way you do work. So you need to have information flow in all these different directions. So keeping a historic track of what you're doing in order to be able to do that kind of review. So this is, the complexity we're challenging. Over the last 5 to 10 years, this has increased, or the complexity has accelerated even more. The number of components to manage has increased dramatically from a capacity and performance perspective. There's an organic growth, of course, but there's also new technologies or new technology layers are being introduced all the time. So the depth of the stack that we're supporting, where it used to be an operating system running on a physical host, soon enough we got virtualization. Now we have containerization, we have public cloud, we have application platforms that in themselves produce or presents new layers to that stack. There's also the concept of scale out rather than scale up. So you include more components to provision a service now than you used to do. And there's also this fragmentation across multiple different hosts or nodes in a cluster, for example. So an application or a piece of business logic is executed in multiple different places at the same time to satisfy the need of the end user. All those things, increases the number of components that you need to manage. You also have an increasing number of technologies, so you keep adding new technologies to the what we need to support all the time. So mainframe, distributed systems, physical systems, virtualized systems, software-defined systems, private public cloud, et cetera, et cetera. So it's an ever-increasing number of technologies that we need to keep track of and need to understand and need to be able to plan for. There's multiple different sourcing models. Once upon a time, on-prem or outsource was probably the two choices you had, and then you introduced a co-location where you could rent space in a public data center and put your stuff there, still own it and run it yourself. Since then, we've moved on over to cloud, where you have infrastructure as a service or platform as a service, software as a service, serverless, et cetera, et cetera. So there's multiple different sourcing models, and each of those introduces different flavors of how you do things, and you need to understand them in order to be able to plan for them. And then last but not least, the increased reliance on IT services from the business. So IT is in many cases running the business, so to speak. So IT is at the forefront of what the business relies on. It's extremely business critical. It's 24/365 operations, continuous delivery of new software updates or new updates to the services you provide means that you release new software in this sort of CI/CD fashion. So it's evolving, it's changing all the time, much quicker than it has been doing, and it's also more business critical. So the demand on reliability and performance and guaranteed capacity, etc., increases all the time. So there's a number of different things that have, made our life more complex, and that calls for new types of capacity management solutions. So the mode of operation have changed from reactive to proactive. In many cases, you have to be more proactive because you need to guarantee service levels. You need to move from manual investigations over to more automated analysis because of the increased scope and the increased complexity. You need to be more agnostic in your approach because the scope means that you can't be an expert and understand the details of every piece of application or every piece of business service that you provide. You have to have ways of understanding good or bad, or recognizing good or bad performance or capacity risk, etc., without necessarily understanding the intricate details of every single application you're running. And you need to have assign more time to strategic initiatives, not being operative, being the in charge of actually monitoring the systems or getting the data in, but more focusing on the strategic side of capacity management, try to add value from that perspective. So those changes means that we need, there's three key items that I'm going to talk about today. So first of all, you need to have full hybrid IT support. The days when we had one or a couple of platforms to support are long gone, and nowadays there's more platforms than we can manage or we can imagine probably, and we need to manage them all, and we need to be able to incorporate those into our capacity management and performance management solution quickly. You need to automate the transformation of data into insights so that you can draw conclusions from the data. So the data has little value. It's actually what you do with the data and how you transform that data. And then you need to get closer to the business. You need to get more involvement into the business. So you need to get your business users or your business stakeholders to take responsibility for certain things. True alignment happens when people get involved and take responsibility for their own success. So you need to work closer with the business and offer them the tools that they can use so that they can get involved in capacity management and capacity planning. So what do we mean by this? If we start with the full hybrid IT support, first of all, a statement. So capacity management is a data-driven discipline. It's very important to remove any barriers from getting access to the right data. It should be easy and simple to get data into the system in order to then transform that data into and apply analytics and transform that data into insights and recommendations. So a simple model says that you collect the data, you ingest the data somewhere, you analyze the data, and then you present the data to a human user. Could also be presenting the data to another system in your environment that then acts on this data and does automated orchestration of your software, of your platforms or your applications, etc. But you need to present the data or the insights from the data in a way so that the receiver can make use of that. So if we start to look at the collection side of it, you could do that in from our perspective, two different ways. Basically, you can either deploy a native data collector. That native data collector needs to collect all the relevant metrics. Obviously, it needs to be granular enough for your business needs. If it's a low latency customer facing business critical application, you probably want to do it on a very high granularity. In other cases, you might be well off with less granularity. It needs to be simple to deploy and maintain. You don't want to spend time maintaining your data collectors. They are basically just supposed to be there and provide the data. You shouldn't have to care too much about it. And they need to have a minimal footprint, obviously. So we don't want to introduce any performance risk or any capacity. Our capacity footprint should be minimal, of course, because we're there to improve it, not to bog the systems down with heavy data collectors. You can also use incumbent third-party data solutions. I mean, every modern organization probably have more monitoring solutions than they could care for. So you need to have a flexible and robust integration mechanism so you can make use of already existing data that is already being collected or being maintained for other purposes to piggyback on that. You need to understand what your requirements are for that data. So in order to do predictions and to do provide high-level insights, etc., you need to have a certain set of data available. So it's important that you understand what those metrics are and what that data looks like. So you can set the requirements up front, and in the case that the existing data third-party solutions doesn't provide the data that you need, you may still have to look at a native data collector, but at least make it clear what are the differences. And that third first-class citizen here, so we need to treat that data as in the same way as we would have done with our own data collectors. So no limitations as what you could do with that data. As long as the data source provides the metrics that you need, it should not make any difference compared to the native data collector. So those are, from the collection perspective. And you want to mix those two probably. So in some cases you have data coverage by third-party monitoring solutions already implemented. For other technologies, or in other cases, you may want to deploy a new data collector. So you want to have the ability to mix those seamlessly. When it comes to ingesting the data into the data store that you use for your analysis, you have two choices there too. So the native data collectors, obviously, those are volatile and they need to store the data somewhere. So those are always going to, write data to a database. You could ETL the data from third-party sources in to build this data source, this global data source that you need for your purposes. The other alternative is to still, ingest data from the data collectors, but then for the third-party data, use federation instead. That's something that it's going to reduce your footprint considerably. It's you don't have to duplicate the data and restore the data another time. So you use the data at the source and fetch the data on demand. This means that you lower the footprint, of course, of you don't have to create another huge data store, but also it gives you more real-time access to the data, however real that third-party sources. There's no way of knowing that upfront, but at least you're not introducing any further delays. An ETL that runs on a schedule, say once a day or once every 2 hours, for example, there's going to be a slight delay in your access to the data or how soon you can get access to the data. So data federation in many cases is actually preferable because it's going to scale better, it's going to minimize the footprint, and it's also going to give you real-time access to all those different types of data sources. Again, you probably need to mix these two. So in some cases, you may want to ETL the data because the third-party data source is not storing the data long enough, or there's other considerations about or limitations in that data source, whereas other are perfectly fine for federation, and you want to be able to mix those without, seeing the difference between them, basically. In terms of what kind of data you want to ingest, obviously the performance monitoring data, so server, storage, network, virtualization, containerization, cloud data, etc., etc. But there's probably also in other types of data sources like incident data, configuration data to keep track of relationship between business services or applications and individual components, business transaction volumes, demand forecasts, costs associated with your hosting of infrastructure or your capital expenditure for that infrastructure, etc. If you want to drive efficiency based on costing, that data needs to be available. Could be response times, end user experience indicators, etc., etc. All those kind of information that makes it, allows you to understand the performance monitoring data better and put it into context. So you need to have versatile integration mechanisms, as we talked about before. You need to have a streaming ability to stream data, so streaming feeds of data, data federation, and ETL. And do this in a number of different ways, using REST APIs, using SQL queries or JDBC, ODBC, using SDKs, using log files, however that data is presented, you need to be able to integrate with it. This also needs to be scalable, of course. That's another requirement. As you see here, there's an awful lot of different types of data sources, and as we concluded before, with new technologies and changes to how you do things, you add more complexity and more layers to the stack, etc. So more and more objects to keep track of. So in vital capacity management, what this means for us, or in our case, is that we have a framework for data acquisition and analytics that consists of components from Apache that are highly scalable, Cassandra database, Apache Kafka event stream that puts the data into the database. Those are the key components, really. But we also have this federation engine, which is true and tried. We've had it for many years. We keep improving it. We keep working on it. So nowadays, we can also cluster this, and we can scale it out across multiple hosts. So we can seamlessly combine those two, so we can either collect the data using our data collectors, but we can also use this federation engine to bring the data in, and you can combine those two. Out of the box, we have support for a number of different technologies. The ones that we see most in the market, for those we can collect the data and store it, but we can also, you or our professional services team can write integrations to those third-party data sources and allow you to also use those as the basis for your analytics and your performance investigations. So the next step, or the next aspect that I brought up earlier in the presentation, was the ability to automatically transform data into insights. So what do we mean by that? So basically, analytics in its simplest form means that you go from data over to analysis, or you have a set of data, you analyze that data, you make a decision based on that analysis, and then you take action. If you look beyond that, there's actually 4 different levels of analytics that you can apply. So you can do descriptive analytics, which means that you're basically just looking at an incoming data stream and determines what's happening. So you can observe what's happening. Diagnostics analytics means that you also store that data, historical data, or you build a historical track of data, which means that you can start to understand why things happen. So you can see the pattern behind different things happening and what led up to it, etc. The next step is to predict what will happen. So that's the predictive analytics. So using the historical data, again, extrapolate that or model that in some way so that you can determine what will happen. And then ultimately, prescriptive analytics is, not just being able to predict, but also when we predict something and I want to counter that, what should I do about it? So how do I mitigate the impact of what will happen? I predict that I will run out of resources, or I predict that the amount of storage available will not be enough. What do I do about it? How much do I need to do? To what extent do I need to increase my capacity, or and something else? So you can do this in a number of different ways. And the prescriptive analytics you can drive. Either you can provide decision support, which is basically providing all the input needed, or all the information needed to make a decision, but you can also use this to drive automation. So you can automate the decision by tying it into some sort of automation solution that allows you to do this completely, close the loop and completely fix the problem. The required skills for doing it is obviously higher the higher up you get here, and a certain level of maturity is required from an organizational perspective, but also the business value. So the further you can get here, the more you can provide in terms of predictive and prescriptive analytics, the bigger value you will bring to the business. So working your way up and maturing your approach so that you can do predictive and prescriptive analytics certainly has a business value that will be recognized and will be valued by your organization. So what do we do in order to sort of provide these capabilities? So we have two ways. So one way is doing statistical analysis, so basically doing linear trending or regression or correlation analysis on the data. You do that, you can do linear trending for storage space, for example. You could do linear trending for a number of different type of resources. You also use other statistical methods in order to make sure that set of data that you're using for your prediction or your trending or your regression analysis is the right one. So you use filtering and selection and threshold comparisons and try to rule out anomalies or outliers by using percentiles or looking for seasonality changes, et cetera, et cetera. So you apply that first to sort of cleanse the data, and then once you have that, you apply different types of statistical analysis to the data. Another way of doing it is using queuing models. You would still use the statistical cleansing methods to make sure that you're using a proper data set, and that data set is somewhat representative of your environment. But then the queuing model is actually a slightly different approach. You use mathematics to apply those mathematics to a predefined set of metrics, which allows you to then do what if scenarios based on that data. So it's two different ways. Statistical analysis is a bit more limited in terms of flexibility. So it could certainly give you a good indicator in many cases, but whereas the queuing model allows you to do more what if based. So you can have varying degrees of change. You can change multiple different things. You can, once you've made the change and the result tells you or gives you a prediction of what will happen, you can go revisit that model and change some of the parameters to try to deal with a predicted change, et cetera, et cetera. So it's a more flexible way of doing it, but they both are useful in different ways. Also, in more modern platforms, for example, containerized workloads running in Kubernetes or OpenShift, as an example, where there's a self-orchestration element where they do complete dynamic load balancing, scale out, and resource provisioning. So it's really hard to determine how they will react to different types of scenarios. And that traditional approach, both for statistical and queuing model technology, where you have a snapshot of data that is supposed to be significant or signify how that application looks like or the profile of that application, it's not necessarily true because there's so many different things that changes all the time. So taking that kind of micro level approach, looking at a specific set of data to represent the application is no longer valid. So rather than doing that, you take more of a macro level approach, where you look at, you make sure that your rules and policies that are applied are the right one, and then you look at the empirical behavior of that kind of platform in order to be able to predict it. So it's a slightly different way of doing it, and it's important, especially if you're starting to use those kind of technologies like containers and cloud native applications running in Kubernetes, that you are able to do that kind of analysis too, because the traditional way of analyzing workloads may not longer apply to those. Once you've done that, you need to present this. So there's basically three main questions that you need to answer. So what is the current state of my environment? Is there anything that I should be concerned of going on right now? What is predicted to happen? That has a slightly lower, there's an element of speculation in that, because you can't predict 100% accuracy exactly what's going to happen, but at least what is likely to happen in my, or predicted to happen in my environment based on certain input. And then, are things running optimally? So the efficiency aspect. So am I sweating my assets to the right amount? Am I using what I put on the floor in my data center, or what I've allocated with the service provider, the cloud service provider? Are those things being used, or is there things that I could repurpose or turn off because they're not being used? All of this needs to be presented in a way so that people can easily deal with it. So it needs to be comprehensive, of course. So it needs to tell you the whole picture. So not just but for one component, but across all the different components like IO, CPU, memory, file space, or disk space, etc., etc. So a comprehensive metric that shows you overall how a piece of technology is doing. It needs to be standalone in the sense that it should be easy to understand, it should be easy to interpret. It shouldn't require you to have any type of contextual understanding. So typically like a RAG indicator, red, amber, green, for to signal the criticality of the issue. It needs to be ranked, so you need to get this information presented in a way so that you know where to take action first. If you have a large scope and a large environment to cover, you need that kind of guidance. So where should I start? Where am I hurting the most? And then the information or the advice that you get back needs to be actionable. So not just telling you that there is a problem, but actually what is the best way of dealing with this problem. So actionable recommendations as well. And this needs to be automated, of course. The days are gone when you could do this as a manual exercise. This needs to be produced on an hourly or daily basis constantly. You need to get this ranked list of problems that you need to deal with and take care of them and deal with them. Those could be things that are not performing right now, but it can also be predictions about the future. So the way we do this in Vital Capacity Management, we have these predictive and prescriptive models that we build based on queuing theory. We have had that technology for a long time. We keep bringing that forward, introducing new technologies, new platforms, new ways of doing things into it. So it's kept up to date. We of course have these statistical functions and operators to do all the kind of statistical analysis we talked about. We have a demand calendar capability that allows us to keep track of those different demands that are scheduled to happen into the future or expected to happen in the future. And then the ability to slice and dice the data into meaningful groupings so that you can symbolize your or emulate your different services or applications or business units or geographies or whatever is of interest to you. So being able to synchronize this with data from the CMDB or a service catalog or from tags in the cloud or from orchestration software, et cetera, et cetera. And now over to the third aspect that we wrote up. So getting an increased business involvement, so getting closer to the business. So why is that important? So if you look at the modern enterprise, there was a time back in the days when most organizations were operated in a siloed fashion. So you had different technology teams looking after different technologies, a storage team, a Unix team, a Windows team probably. Eventually there was a VMware or a virtualization team probably, etc. And then you had different application teams that were more concerned with the business logic and the actual applications and how those applications were being maintained. And then you had a project management office that put together different projects, different initiatives where they pulled people in from the technology and the application teams, and then they worked in a project, typically in a waterfall model over a certain time or during the duration of that project, and then the project was finished and the application got launched, and the technology and application teams looked after it. So it was a very siloed approach. People, rarely met anyone outside their own silo, and let alone talk to them. This was eventually replaced by more of a plan, build, run approach, where you had specialized teams that were in charge of planning for applications and workloads, a team that was focused on building it, so the development of it, and then a team that was supposed to run it and keep the lights on. This allowed for specialization, and you could scale up easier, but you could also source these things independently. So this is when outsourcing started. For example, you could very well have someone else run your applications for you. You didn't have to have the same the teams that were building it also being involved in the everyday running of it, for example. So you separated the operational and the capital expenditure in a much better way. This has gradually been, or starting to be, replaced by more what, there's no real, established name for it, but, in this case, I refer to it as the digital business, where you have product teams that has a much more involved in the development of the product. They are actually the ones who define the product. They're also the one who run the product. So you have a business embedded operating model where you have these CI/CD, continuous integration, continuous development product teams that are not just responsible for doing the application development, but they're also involved in how it's going to be operated and how it's being operated in everyday life. Since you have these shorter CI/CD cycles, etc., it's very hard to keep a distinct or make a distinction between development and operations. So capacity management activities needs to happen on both sides of this line. So it's no longer just the specialists in the planning department that are involved in capacity management, but it's actually people out in the front line managing the application, developing the applications needs to be involved in this too. So what does this mean? So we need to have tools that allows us to be more business embedded, because it becomes the responsibility of less experienced user. It needs to be simpler to use. So we need to simplify our workflows. The application needs to support a different type of users. So simplicity, so you have to have guided workflows that provides this self-service capability so that you can have people that are using the application more rarely, understand it and grasp it. You need to have clarity. So those people probably don't have as much insight or as much context or as much experience and as much of a reference framework to pull from. So the device and the recommendations needs to be prescriptive. They need to tell more in detail what they should do. They need to be agnostic. They shouldn't assume that the consumer of the information has the full picture. And they need to be created automated or automatically. So they need to be available on demand. You can't expect those people to sit and wait or run a report that takes 2 hours. The data needs to be constantly reproduced, being available to them at their fingertips when they need that data. So those 3 things, simplicity, clarity, and on demand, are key aspects if we want to get more business embedded capacity management. While we do that, we still need to provide capabilities that satisfy the needs of experts. So it's not like capacity management or capacity managers are going away, but they need to work hand in hand with more business-oriented users. So we still need to provide the expert capabilities that advanced capacity managers are going to look for. So the way we do this in vital capacity management, again, we're building the stack here. We have 4 different components. So we have something we call key performance indicators that gives these high-level indicators of, supposed to bring awareness to health, risk, and efficiency issues. We have performance monitor tool component that allows you to do troubleshooting, get access to all the detailed data that is being collected or being stored. Planning component that allows you to build your own what if scenarios, so focusing on specific business events like a migration from a legacy platform to a new one, or a growth scenario, or anything that requires you to plan and to do an evaluation of different type of scenarios. And then of course building your own analytics, so putting together dashboards or reports that speaks to your business specifically, where you organize the data, slice and dice the data with your grouping capability, and then applies different statistical methods, or build queuing models of your data, and then present this data in a format and in a way that makes sense to your business users. So the three first components to the left are designed to do one thing, and one thing really good, but no matter how good we've designed those, there's always going to be other use cases that we don't support with those. So that's where our automated analytics comes in. That allows you to build or complement all of those things with your own analytics. And then these are connected together, so you can move between them. So if you are made aware of an issue over in KPIs, you can easily move over to troubleshooting or planning mode very quickly. So they're all connected, interconnected, and allows you to move between them without losing the context or having to start over at any point. So all of those are requirements from a modern type of capacity management solution. So how does this generate value to the business? So the way we normally position capacity management is it has basically three main business benefits. So the first one is it allows you to reduce your risk, so you can better react to changes in your environment, and you can maintain your quality of service basically, or you can make sure that you can introduce changes without negatively impacting the quality of your services. The other one is to increase your efficiency, so make sure that you're using the right amount of resources, not too much, so not compromising the quality, but at the same time running as lean as possible, and making sure that you sweat your assets that you already have before you invest in new assets, whether those assets are your assets in your data center, or if it's something you subscribe to from a service provider. And then the third component is the agility aspect. So that sort of is a byproduct of in reducing your risk and increasing your efficiency. It allows you to act more quickly and more confidently on new opportunities. So if you know where you are from a capacity perspective, or capacity positions are, it's much easier to embrace or explore or make the most out of new. So it's basically becoming more dynamic in how you operate your IT, and by that allowing you to go after new business opportunities in a better way. These things happen in a certain order, and shouldn't expect everything to happen overnight. We have a maturity model that we use in order to guide our customers and our business partner in how they should implement capacity management. This is one of my pet peeves that I always keep talking about. So if you look at this model and then you contrast that with, so you have this gradual process maturity. Same goes with business value. So as you grow more mature, you're going to increase your business value. If you look at that from these three different aspects of reduced risk, increased efficiency, and improved agility, they happen at a certain order. So at the lower level of maturity, it's a certain set of capabilities that are going to benefit you, or that you're going to be able to benefit from. So, and then at the higher level of maturity, you take this to perfection. So you start to replace manual processes and eliminate risk through standardization in terms of risk reduction. You can start to defer costs by doing just-in-time investment, and you can start to allocate cost by activity out to the different business unit, and then you can start to also, more confidently exploit new business opportunities. So gradually, you will see, value increasing in each of these different areas when you do your, as you mature your capacity management discipline. So I have a poll here that we can take. I don't know how we're doing on time here. Yeah, let's do this. So there is a poll that I'm prepared where we can look into what I would like to find out how you are perceiving this. So what do you believe is the primary driver for capacity management in your organization? So the poll should be up now. I'll give it a few minutes here. Starting to get there. I have about half of you have responded. If you could please insert your I think I have most people have responded now, so I'm actually going to close the poll. And so the result is quite interesting. I hope you can see this now. So about half of you said that increasing your efficiency was the main driver for doing capacity management. Doesn't mean that it's a binary purpose. There probably have multiple different purposes by doing it. 25% of you said reducing your risk, and 25% said improving your agility. So surprising. I mean, many times we see that reduced risk is the main driver, but that's of course, there's different organizations have different priorities, I guess, and in this case, increasing efficiency was obviously the higher one. Okay, thank you very much for participating. So I'll move on here. So this brings us over to the last slide and the summary. So what we believe is important when you are shopping or looking for a capacity management solution or some capacity management tool. First, support for your whole hybrid IT environment. As we said before, you keep introducing new technologies all the time. There's nothing as standard, nothing as standardization anymore in the sense of platforms, etc. You're going to see a lot of different types of technologies, and those all needs to be managed. You need to provide both lightweight data collectors for those systems where you have specific needs, and then also data federation to make use of your previous investment. So if you already rolled out enterprise monitoring solutions, you probably want to use those to the largest possible extent, but then to cover gaps, etc., you may want to use native data collectors that brings that data in. You need to scale to manage the increased scope and complexity. As we said before, the number of new components introduced by adding more layers to the stack or by growing your IT, you need to have a solution that can manage that, both from an automation and from a scalability perspective. You need to offer flexible data integration mechanisms. So new platforms have new ways of providing data. They many times come highly instrumented out of the box. So you can benefit from that instrumentation, but then you need to be able to integrate with that and get the data into your capacity management solution. So you have a single pane of glass where you can do your analytics, etc. The tool needs to help you prioritize your efforts, so you know where to start. Where are we hurting the most, or where are the most important components of our environment that are inefficient that we need to deal with, etc., etc. It needs to save you time through automation. So gone are the days when you could care about individual systems or individual servers or individual infrastructure. Nowadays, it's more about automating the identification of root cause and finding the issues, and then hopefully also automate the fixing the issues, but at least, you know, automating the identification of issues and serve you with prioritized list of what you should do. It needs to support scenario-based planning. So still there's, you know, business as you get closer to the business and as you start to do work more with business aware capacity planning, you need to have the ability to do scenario-based planning. It's not enough just to extrapolate a historical trend. You also need to understand, so what happens if we do an acquisition of another company, or if we introduce change that is not represented in our historical data, how will that impact us? So having these different levers that you can pull in your predictive analytics is really important. And then last but not least, be easy to use. If we're going to become more aligned with the business, we need to invite the business into using our tools and our solutions in order to, you know, do some of the work themselves, and then the tools need to be easier to use. They don't have the expertise, they don't have the time, they don't have the understanding, the context that we have when they are using these kind of solutions. So the solutions need to be more adjusted to their needs and to their situation. So with that, I thank you for your attention. I said that we were going to do questions at the end if there were time. I think we are out of time. We're actually 5 minutes over. So I think we need to stop now. But thank you very much. And if you have any questions, please feel free to email me. This presentation is recorded and will also be released or will be available, so you can watch it and share it with other people as well if you want to. Thank you very much for your time, and have a great day.